So we're here to talk about OpenFaaS and Linkerd. We'll explore them a little bit separately, and then why we've combined them, why we think they're powerful as a combination. And then I want to show you OpenFaaS Cloud and what that can bring to OpenFaaS and to teams. But we also had to do a bit of work around security, and that's involved Kubernetes primitives, but also some stuff we had to build in as well. Once we've been through that, we'll then look at what is the future work where we can make more use of Linkerd and potentially other service meshes, and what do we want to achieve through OpenFaaS Cloud going forward. Okay. So it's at OpenFaaS and at Linkerd if you want to tweet, take photos, would be much appreciated. Now, OpenFaaS started in 2016. I don't know, has anybody here used it or heard of it before? Yeah? Oh, wow, great. It's good to have you here. So I won't bore you too much with the details, but I wanted to kind of have portable serverless code and function experience that I could run on containers. And that was really the catalyst for it. And from there, it's grown massively. I mean, there's 2,000 people on Slack now and over 250 contributors. Perhaps some of you in the room have contributed to the project in some way. And I think the reason for that is the values that have driven it forward. We've always tried to focus on developers, trying to put their needs first, having a great CLI, getting people to contribute there. It's actually the area we've had the most contributions. Building a UI so that operators can come along and see what's there, but also keeping it very simple and defending that simplicity so that if you do want to use Kafka or something that's particularly heavyweight, it's not mandatory, it's something you can opt into. And finally, that community centricity is the key to growing an open source project, and it's great to have the OpenFaaS community here today. Now, this is hosted by OpenFaaS Limited. I work on this full time, and also with a bunch of other committed open source contributors. So that's OpenFaaS. To kind of context set why we need OpenFaaS, we could look at cloud functions, and I'm calling this serverless 1.0, the original. And they pioneered some things, and there's a great experience here. And if you use this and it suits your needs, you should probably stick with it. But the problem that we found was that the programming language, let's say Node.js, the signature of that function would be different in different platforms. And so if you're going to migrate something, you're going to struggle there. The zip file is not the best kind of packaging format that's out there. There's certain things that we can do better. For instance, if you want to build a graphical library, you're going to have to download the Amazon Linux, build against it, and upload that. And as we all know, at KubeCon, Docker containers kind of set the way. You're then also going to run into different problems when you move to something like GCP, and you have different regions available, a different API. And there are some efforts to try and consolidate it, but in the enterprise, we don't really have an answer. And when it comes to microservices, you're kind of stuck with that as well. You can't lift and shift a big PHP Laravel application into one of these easily, right? And so that's what we're aiming to do, is kind of find a solution for that. And the solution, I believe, is serverless 2.0. And here we can actually run any code we want because it's going to be in a container. Now, as long as you've got a HTTP server inside your code, you're good, right? So if you've got Express.js or Sinatra, maybe Ruby on Rails, we can just package it for you. If you've got a binary like Bash, we have a wrapper called the Watchdog, and you can put that in a container and have that give the HTTP interface, right? And this is the important thing that lets us have that portability that we didn't have before. We also can run that anywhere. Now, it's important for debugging, but also for consistency to be able to have that same experience on this laptop as I have on Amazon, right, in the cloud. And that's something that we struggled with 1.0. You can also auto-scale, right? So we can have horizontal pod scaling. We can scale adding new nodes into our clusters. And you can scale to 0. So if you've got a microservice, you could deploy it to OpenFaaS and immediately get those benefits, right? So who's created a microservice or deployed any HTTP server on Kubernetes, right? And we all know it's pure joy. Do you want to tell us what we'd have to do?
Well, having deployed quite a few applications, not necessarily a Node.js application, but we have to write our code to serve the pages. So here we see an index.html page. So I don't know, that's 30 lines of code.
Okay.
We have to have our file to manage our dependencies, so another 24. And now
Keep up.
yeah, okay. And we have to have a handler to handle the requests. And then we have to have the service resource to deploy to Kubernetes, the deployment resource to deploy to Kubernetes. And
how many people's deployment files look that big? I think this is getting off lightly. And then, anything else?
there it is, the ingress resource so that we can actually route traffic into our service.
Are we done? No. Oh,
Nope.
there's more.
Dockerfile. Yeah, oh yeah,
Okay.
you got to put it into a container.
And now what can we do?
Now we can serve hello world.
Yes. But what if there was an easier way? What if we could think back to object-oriented programming and this idea of abstraction and do not repeat yourself? And that's what we've done here. Now, those YAML files we'll come back to, but the Dockerfile and the index have been abstracted away into a template, and that's all we had to write, 3 lines of code. Okay. Now, you can have a Dockerfile as well. We'll get to that. And this YAML file here is an OpenFaaS YAML file. It can be a CRD, so if you're using GitOps or Flux, that's great. You don't have to abandon that. But here you can just set your memory limits and secrets, environmental variables, configure it very easily. So Dockerfile is a fair game. Like, I want you to take this home. If you don't know this about OpenFaaS, you can get a Ruby on Rails app, and if you listen on a certain port, you can deploy it in OpenFaaS. You'd be good to go. Now, some of the customers and end users here use it as a pure serverless functions framework, and others use it as a container platform. DX are a company in Norway, and they're one of the leading brands for e-ticket sales. What DX do is they have a PHP Laravel monolith. It's huge, and they really didn't want to break it apart, so they wrote a Docker file for it, put it in a Git repo, and now it's on OpenFaaS on Kubernetes. Right? Really that simple. They also have a big C# monolith, and they're applying something called the strangler pattern, where they cut off little bits of it until there's nothing left, bringing each part across as a separate function. LivePerson use OpenFaaS purely as a FaaS, and they embedded it into their UI so that customers, when they're chatting to operators, they can have code flows execute. So if you are buying a pair of Nike shoes and the customer rep is rude to you and you rate them bad, it can send an email to their boss afterwards, right, for example. And you, as a customer, can write the code and extend their platform. Vision Banco got a lot of stability by moving to Kubernetes, and it's not all due to OpenFaaS. I mean, don't get me wrong, I do really like it, but it was moving to Kubernetes and having something to accelerate that journey for them. So tell us a bit about Linkerd, then.
Yeah, Linkerd. Well, thank you, first of all, for letting us be part of the OpenFaaS experience.
You're welcome.
Linkerd is the only service mesh in the CNCF as a project. There are other pieces of service meshes in the CNCF, but Linkerd is wholly donated to the CNCF, and that's important to us because we appreciate the code of conduct and the open governance that goes along with that. Linkerd is meant to be transparent, easy, zero config, and easy to install. So in under 60 seconds, you can install the Linkerd control plane, begin to deploy your proxies, and immediately get metrics out of that. Metrics that are actionable that you can get valuable information from. It's loved by engineers. We've got a huge community, not unlike OpenFaaS, and that's why I think these two projects are complementary not only technologically, but also from a social perspective as well. And along with the metrics, you get these deep runtime diagnostics so that you can debug your application in real time, even if you want to see network traffic happening straight away in real time live.
And it's great to know that it's not only an incubating project, but there's many production users, both of Linkerd 1 and 2.0, and the team are absolutely great. I really love getting involved in the community. I've been to some of the online calls, super organized, really well run, very welcoming.
Thanks.
So, you know, like, why would I want to look at Linkerd? There's all of this stuff about service mesh. People are upset about it. People are excited about it. Look, Linkerd is very lightweight and easy to use. And don't get me wrong, there are users of OpenFaaS that like Istio too. But I just found it easier to use. And I particularly like the traffic splitting capability. This is where we can do canaries and progressive deployments without changing OpenFaaS. And I think that's why the Cloud Native Computing Foundation is so great. You don't have to rewrite everything yourself. You can tap into this existing code and communities. We're actually going to look at mutual TLS in the dashboard today, and they're also very important, particularly for customers that might be running in environments where they need compliance. Linked's dashboard is really great. I mean, if you install it, it's probably the first thing you see. And here I've got a topology of what's in the OpenFaaS namespace with OpenFaaS Cloud. And if you've deployed OpenFaaS, you'll notice there's some extra stuff here, and we'll cover that in a second. So what's the difference between OpenFaaS and OpenFaaS Cloud? OpenFaaS is this platform I just introduced to you, but quite often somebody like the person that's sent to KubeCon, like Carson, for instance, or one of you other guys or girls, will be really into containers, really get it, but you get back to the office and you're like, I've got this thing, it's great. And they're like, what's Docker? What's Kubernetes? Have you done your CKAD yet? And so what we do is allow OpenFaaS to answer that question and allow somebody that's super technical, a platform engineer, to come back and deploy this for their team. Then you're going to get built-in CI/CD, a dashboard, and authentication out the box. So you can go from 0 to all of that in however long it takes you to set up your EKS cluster, right? Rather than having to build that out in your platform engineering team. And that's really what we're trying to show you today. At conceptual level, anybody that's familiar with GitOps, Argo, or Flux will know that there's this idea of pushing code into a GitHub repo and getting an endpoint out the other end, and that's what we've got here. We commit our code into a Git repo, and there's an integration between the Git provider and some code, a webhook receiver. It receives the webhook, validates it, clones the set repo, builds a Docker image, that's our artifact on Kubernetes, puts it in a registry, and then in this instance, we're going to deploy it on the OpenFaaS gateway for you. At that point, it will show up on your dashboard. So this is a conceptual overview, and then we're going to dig in a bit more depth at each part of that pipeline. Now, the features that you'll get is the CI and CD. So you commit to master, it will build the code, it will deliver an artifact, and you'll have an endpoint, just like that. GitHub.com is supported, and GitLab. So if you're self-hosting, GitLab is another option for you. You can have runtime secrets encrypted with Bitnami sealed secrets, and you can also get a dashboard. OAuth means that we can have these permissions for teams so that you can't see my functions, but if we're in the same organization, we can share. And then you both have logs for builds, but recently, a chap called Alistair in the UK came up in the GitHub and in Slack, and he was like, I really want to get involved. So we've got all this stuff. Can you add logs, runtime logs to OpenFaaS Cloud? And he did it in about a week. It was amazing, and you'll get to see it in a second. So OpenFaaS Cloud.
Yeah. So if I wanted to get started with this, what would it take?
Yeah. So I believe you tried it out this morning in a community
yeah.
cluster.
Yep, on the community cluster. Prior to that, I had worked to install OpenFaaS Cloud on my own cluster as well with your Bootstrap application.
Which is free and open
Yep,
source.
all open source.
Yeah. So you can try the community cluster, or you can run the Bootstrap. This is what it's going to look like when we see the commit detected on GitHub. So it's super integrated. And then we'll get a dashboard with what we've deployed. Now, what do we want to do today? Do we feel like a microservice with a Dockerfile, or do we want a function? So Dockerfile, Node.js. Oh, come on, I wanted to do that one. I did, actually. I had it already. OK, so we're doing a function. Right. So first of all, I've got a GitHub org, and it's called logic. And we're going to create a repo. I want to be a microservice.
So this is a brand new repository that you're creating. Is it public or private?
This one's public. Private's good too.
OK.
We're going to clone this. And you'll notice I don't have Docker running on my machine just yet. FaaS CLI store list. We've got a template store, and that's the function store. We want the template store list. And we'll see all the different options there. I'm going to pick Node.js 12, FaaS CLI template store pull, Node 12. And that's going to come from a GitHub repo. Template store, what have I got wrong?
Isn't it new? Is there a new?
FaaS CLI template store. Let's try another one. Oh, I know why. This is a standard template now. Okay. FaaS CLI new. I won't bore you with the details here, but we're just going to scaffold the function out. And language is Node 12. And just hello cube taco, right. So we're all up and running now. And I can look at the code. Remember, the stack YAML is that minified version of what you'd normally be deploying. You can have a CRD if you want it. And then I've got my code there. It's just going to say what the input was. So put receive taco instead. And remember, we don't have anything running on a local computer. There's no Docker. And I'm just going to rename this to stack YAML. That's how we like it. Initial origin master. Okay. So in a short period of time, we'll see a git commit status appearing here. And it's going to tell us what is discovered. So you have more than one in that repo if you want. And this says GitHub Actions, but it's GitHub checks and statuses. We're going to get the logs. And I can click on this. And if I had a unit test, for instance, that failed, it will block the build, tell me what went wrong. The logs are now here. And that was 11 seconds from git push. It built a container, pushed it in a registry. It's live on my Kubernetes cluster. And we got our taco, right? What do you think?
It's pretty impressive.
Yeah?
That's great.
If we get time, I'll show you the Docker. Sorry, okay, someone's taking a photo. There you go. If we get time, I'll show you the Dockerfile version as well, which I really like. Now, it doesn't end there, because you thought that was the end of the demo. It's not. I'm going to show you my dashboard. So dashboard, and this is the organization. Now, if I open an incognito tab and try to log in, it will use two-factor auth. So it's nice and secure. And here's my service. I can look at the runtime logs. Thank you, Alistair, for building this. And then I can also look at any statistics, the Git char, and the metrics all in one place. So, case study, because you want to know that this is useful for real work. DX have their PHP Laravel service. All they had to do was build a Dockerfile, and they've been able to port it across. They also needed, well, their CTO believes in using SaaS products, right? He would have used Lambda if it was suitable for what he wanted. He's using OpenFaaS and EKS, but he needed support for ECR, and so through OpenFaaS Limited, we've been able to implement that for him, and now we can push into ECR. They're a really great customer, and learning a lot, getting a lot of feedback as we go along. And if you're building open source, I think it's really important to get that kind of feedback. Now, the other side of OpenFaaS is community centricity. If someone could take a photo, Rajat will be very happy he asked for that. Rajat works for Proofpoint, and he has this bot. And we heard from Kelsey about this idea of inclusivity and being able to contribute. There's this theme of everyone being, accepted at KubeCon. Well, what better way to get involved than finding a good first issue to work on? Microsoft, Google, Docker, JetStack, OpenFaaS, perhaps even Buoyant at some point, are using this bot. If you install it on your org, it's completely free, it's very loose permissions, and as soon as you tag something, it will tweet, and then contributors can come and find work.
Quick question, Alex. When you're tweeting through the Twitter API, don't you need a secret? So wouldn't he have to put his secret inside of this application?
You'll need 4 secrets, right, if you've used it. And yeah, you're right. And you really don't want to put that in a Git repo, even if it's private, right? So we're using sealed secrets from Bitnami, and that allows us to encrypt it one way when it's attached in the cluster, it can get read back again. Okay, so a little bit more technical now. Let's look at the pipeline. There's two things that GitHub will do here. There's no API for OpenFaaS Cloud at all. You can't delete a function. You can't create one. The API is Git. Okay? Here's the two things you can do. You can push code, which will result in the GitHub push function running and the endpoint being built, or you can add a new repo or delete one. If you remove a repo, we remove the functions that were associated with it. And that's it. Right? Super simple. Now, this is the CI/CD pipeline. I'm going to go through it in stages. The first stage is git tar. Here, we will clone your GitHub repository using a secure access key. We'll then pull in the template or the Dockerfile, depending on what you had, shrink wrap it into a tarball, and that tarball means that we can decouple the pulling and templating. We'll then put that into the OF builder. An OF builder we'll call BuildKit, which is a project you should really try if you haven't yet. It's super fast caching builder, runs as a daemon. And if that succeeds, it will go and pop it in the registry for you. So for ChrisUnit.dx, that will go into ECR. Next, if it worked or it didn't work, we'll put a build log in S3, and you can use Minio if you're on premises. Finally, those secrets will get imported, and a sealed secrets controller will decrypt them and make them available for the user. Right? And you see at the bottom of the screen, a post or put into system function. That's the OpenFaaS API, and that will either update or create your function or microservice. So that's the CI/CD bit of it. The second part of it is the dashboard. And you'll see these are actually functions hanging off the OpenFaaS. So someone said to me, if OpenFaaS is so great, why don't you build OpenFaaS with OpenFaaS? And I said, OK, I will. And this is what we got. The dashboard does a get to the list functions function, which has a user parameter that goes to the OpenFaaS API, filters according to metadata we've got there, and draws the dashboard for you.
Where do you store that metadata?
Well, really didn't want to have it in a database, you know.
That's fair.
Because Kubernetes is stateless.
Don't want to manage storage.
No, we really don't want to do that. So what we did is stored it on the deployment. And you can see you have a Git owner, you have the repo, you have the SHA, and then we can use that to draw the data live. This is an example of how the sealed secrets works, because we wanted to look a bit into security in this talk. You have your plain text secrets. You run FaaS CLI Cloud Seal. It will generate this encrypted version, and then when it's uploaded, it effectively gets unsealed and attached again. We only need to give you the public key, which is non-confidential, and we keep the private key in the cluster. Now, within Kubernetes, there are a number of ways we can get multi-tenancy and enhance security, and I'm sure people will come and tell me afterwards that I've missed a couple, and I know it's confusing, it's very hard to get it right. But we're applying memory and CPU limits across the cluster to try and help reduce people exhausting the resources. Namespaces allow us to split per user or org, and then we can apply quotas. And we're not doing the quotas yet, but it's on the horizon. Within the quotas, you could say you're only allowed 5 pods, or so many secrets, or so many ingress resources. Network policy is something we do apply, and that stops any user functions talking to any other user functions, or back to that control plane. Because the last thing you want is somebody to get in there and write some code to start deleting stuff. Right? Pod security policy is something that is quite advanced, and a contributor in the open source community is helping us implement that. Right now, because we don't have that API and everything gets in through Git, it's not quite so important for us. But if you're running stuff where you're allowing your users to deploy manifests, you probably need to be looking at this. Now, if you catch Gareth Rushmore, if you want to catch his talk, Open Policy Agent can also help you verify and validate what you're applying into your cluster. Finally, CRI, Container Runtime Interface, can allow us to use something like Kata containers or VMs to have additional isolation, so that if somebody found a vulnerability in Containerd, they may not be able to break out. Now, what we've done is, by default, applied a read-only file system to everything that's deployed. Now, that's not the case in OpenFaaS by default, but you can opt into it. In OpenFaaS Cloud, it's policy. We're using non-root so that you can't escalate privileges. OAuth means that you only see your stuff or stuff in your team. HMAC is used to validate the webhooks that come from GitHub so that we know that it really is GitHub and we can delegate your user authority between them. And the public TLS is built in, so Let's Encrypt can be quite tricky to configure, but we do that all for you. You say what your domain name is, and we'll generate it. Sealed secrets we covered, and it's a bit an army project. And also, there's a default configuration that applies some basic rate limiting, so if that is on the internet, people can't abuse it. Finally, back to Linkerd, mutual TLS.
That's right. So Linkerd out of the box provides mutual TLS to all the proxies which are injected with the Linkerd proxy, to all the services that are injected.
Why would I want to do that?
Well, you want encryption. You need to be safe, especially if you're working in a multi-tenant environment. So looking at this slide here, we see that we've got multiple services in the OpenFaaS environment that communicate with each other.
Okay.
Alongside those, or underneath those, I should say, is the Linkerd proxy. Linkerd proxy has the certificates, and now the services no longer communicate directly with each other. Linkerd is managing all that traffic in and out and securing it, encrypting it along the way with a trust store, a certificate from the trust store in the control plane.
Wow. And I get all that just by installing Linkerd?
Just by installing Linkerd.
Wow.
Yep.
I'm sure there's some people that would rather do it themselves, and I'm not one of them. So this is what we get, and I really love the CLI with Linkerd, and this is the edges command. What it allows me to see is what are the edges of the proxy, how are they talking to each other. And I know you probably can't see that, so I'm going to help you. The first thing we've got is Nginx talking to the edge router. This is the bit that decides what user to serve and what function we're looking at. You can see at the far end that that's secured. Next, we go from the edge router to the gateway. And the edge router is the new bit. The gateway you guys probably already have. Then the gateway goes to my pod, Alex Ellis, run on Kates, and we're good. So we're TLS served on the ingress controller. When we got to there, we've got TLS all the way down into our code. Now, during auto-scaling, you will see that Linkerd is also picking up metrics, and there was a spike in traffic. And then the latency went up because we needed more capacity. That was added into the cluster, and the latency in the bottom corner there dropped back down again. And this is all built into OpenFaaS. And again, there's a policy in OpenFaaS Cloud to keep it within sane limits. If you want to get OpenFaaS Cloud rather, then there's a bootstrap tool that you can run. Now, this will install a whole bunch of things. The first thing is the functions that make up the build pipeline and the CI/CD and the dashboard. Next, installs BuildKit, and there's a non-root configuration for BuildKit and an unprivileged configuration as well. Akiro's done a great job maintaining that and helping me out on the project, and so that means you can have these secure builds. Helm can be used with or without Tiller to then install the OpenFaaS gateway itself using its chart, Nginx using its chart, Cert Manager will give you the certificates, sealed secrets, and then we add Minio by default, but if you want to use your own S3, you can just configure that too, right? So you'll fill out a YAML file with your domain name, your email address for your TLS, anything else you want, if you want the read-only policy across the board or not. And then finally, it'll probably take about 100 seconds, and you'll have all of that deployed. Right? So what I demo to you, and get on your own environment. And if that's a bit too much and you don't want the TLS and the DNS, and you're like, Alex, I just want to try it, that's okay too. And you can look on my blog and have a quick start that just turns those bits off. You can just play around with it and see if it fits your needs. So the future work we have in mind, as we just come up to close the talk, is this idea of feature branches. And this, again, this is me saying open source needs to listen to real users, and our customer at DX needs a preview branch. So right now, you can install OpenFaaS Cloud and point it at a branch. So one that does master, one that does staging. We want to combine it into one cluster. Build time secrets is something we're trying to work on. If you've got ideas of how we could do this, please come and talk to me. Input's welcome. The quotas, and also I think static analysis is interesting. Think of tools like SNCC that are able to look for vulnerabilities in your code. Within Linkerd, I know Oliver's here, really looking forward to mutual TLS for TCP. There's part of OpenFaaS Cloud that isn't meshed at the moment, which is the asynchronous bus for NAT streaming. We use that to run the builds. Canaries would be great if they were built in. And using the SMI spec, we don't have to change OpenFaaS. Chargeback. This is something that enterprise is really keen on. The ability to do that is enhanced by looking at the bandwidth metrics in Linkerd and then being able to bubble that up through OpenFaaS. And maybe even like retrying automatically, as people have asked for that too. So just want to sum up, because I know we're almost out of time. OpenFaaS Cloud is OpenFaaS, but automated. The build pipeline is done for you. The security is handled for you. And the management of that too. I'd love you to go and try it out. And this is how you can get involved. We've got a GitHub repo. Feel free to take a photo of this. This is the main repo of all the code. And there's a lab. If you're just interested in OpenFaaS at the moment, you've got your own pipeline. You can combine it with Linkerd, and you can try all this cool stuff. Feel free to send pull requests to that too. And both of our Slacks are looking forward to seeing you there. So, okay. Thank you. Thanks.
Thank you.